Hey guys, Chapter 6, Section 4 video. We are going to work on what types of growth can interest have. So, in the last few videos, we've been talking about simple interest, which is when your bank account can earn money for just storing your money at a bank. Or we've talked about interest when it comes to loans, when you borrow money, how you have to pay extra interest. And that simple interest that we keep talking about is called simple because the formula is dang simple. It's I equals PRT. P is principal, R is rate, and T is time. Now, we've already practiced this formula quite a few times, but I want to point something out to you today. If you were to get a statement home in the mail from your bank, sometimes the bank will send you a graph of your money, like if it's growing or if you're spending. And if you were to put money in a bank account and earn simple interest and do nothing else, the growth in your bank account would be totally linear. Simple interest grows at a linear rate. In fact, I'm going to write that down. It has linear growth. But not all interest is set up the same way. So today we're going to introduce a new type. It's called compounded interest. Now, compounded interest is a little bit more complex. The formula, let me show you the formula. This is the formula. Definitely not as simple as I equals PRT. The formula is Y equals P parentheses 1 plus R over N, all to the NT power. Now, what does this formula mean? First off, Y stands for the balance in your bank account. P is still the principal. R is still the rate. T is still time, so those variables have not changed. There's your PRT. But the new variable, N, is the number of times it's compounded per year. So what does compounding mean? Well, compounding means to add on to something. So let's say you got your interest and it was given to you every month. The bank paid you interest every month. Well, each time you get your interest, the next time you get interest on your interest. So if you're getting a 5% interest rate and at the end of the month they pay you that 5%, the next month you get 5% on top of the last 5%, if that makes sense. You're getting interest on your interest. So it's kind of like a snowball effect where you push the snowball down the hill. Have you ever seen that in cartoons? You push a little snowball down the hill and it starts growing and growing and getting bigger and bigger. That's kind of what compounded interest does. Let me show you a problem. We'll do an example. Let's say you deposit $100 in a savings account that earns 6% annual interest, compounded monthly. Compounded is our clue that we're going to use the compounding formula. So how much money will you have earned after 1 year of investment? Let's try this. Well, because it's compounded monthly, I know I'm going to use the compounding formula. So we're going to write down the formula, Y equals P, parenthesis 1 plus R over N to the NT power. Then we're going to go through the steps. What is the principal? What is the starting amount of money that you have? Well, you deposited $100, so that's your principal. Our rate is 6%, so we get a 6% rate. And we're getting it as annual interest. So for time, we're doing this for 1 year. Now for N, it's being compounded monthly. How many months are in a year? Yeah, 12 months in a year. So our N is equal to 12. So our job is to take our PRTN and replace it with these numbers. So it's going to be Y equals 100, parenthesis, 1 plus 6%, but we're going to make that a decimal, 0.06 over 12 to the NT power, so 12 times 1. Now, here's our setup. We got to solve and simplify. So I'm going to go through this probably by starting with the inside of the parenthesis first. 0.06 divided by 12 is 0.005. So I'm going to add 1 to that and get 1.005, but it's to the 12th power. So using my calculator, I'm going to type in 1.005 to the 12th power, which is some huge decimal. I didn't even put the whole decimal in there. And we're going to times it by 100. Now, it's about this. I'm going to have to round a little bit. It's about 106.17. So this is your balance in your bank account after 1 year. You started with $100, but at the end of the year, you have $106.17 from that interest growing. Okay, so now we're going to put this in a table. We're going to make a table that measures the time in years and your balance in your bank account. And what we know is in 1 year, you have a balance of $106.17. But what about 2 years? Well, if it was 2 years, then we got to go back. Okay, so what we're going to do is we're going to go back where we had put in time is equal to 1 year, and we're going to change it to 2 years, which means in our formula, instead of 12 times 1 for the power, it'll be 12 times 2. So that changes our math a little bit. Now we're going to have 100, parentheses, 1 plus that 0.005 to the 12 times 2 power. That means 1.005 to the 24th power. So again, you have to use a calculator to put these powers in. Now, if you don't know how to do this in your calculator, you totally need to ask me in class or look up a how-to video for powers and exponents. So you're going to get 1.127 something 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 times 100, so about 112.72. So the balance in 2 years' time has increased up to $112.72. Okay, well, what if we went farther out in the future to like the 10th year? What would that be? Well, we would go back and we would change it to 10 years for time, so it'd be 12 times 10. So we'd be doing 1.005 to the 120th power. Oh man, that decimal is 1.819 times 100, so it's $181.94. So in 10 years, if your money is just sitting there doing nothing, it would have grown to $181.94. And you didn't do anything, it just sat in your bank account. That's compounded interest. Now, why am I showing you these numbers? Well, we're going to graph them and actually look at them and see what they look like. So on a graph, obviously we don't need negative numbers because we're not spending money right now. No negative values, we're just adding interest. I'm going to just label it time in years and balance. And the years went from 1 year to 10 years, so I'm just going to label it 1 to 10. But the balance is up to $181. So I'm going to do this thing where we put a little break in the graph. I don't really want to go from 0 to 181. So I'm going to cheat and break and start at 100 and count by tens. 110, 120, 130, 140, 150, 160, 170, 180. And that little break symbol in the corner is just a way of, it's kind of like a cheat to make your graph be able to like jump ahead to some numbers. So we're doing that so we can plot the points because $106 is going to be right above the 100 mark for year 1. Oh, and I put at year 0 just right on the $100 mark because that's how much money you started with. On year 2, there's $112, and on year 10, which is way out at the end, it's $181. And if you can't tell, it's supposed to look kind of like this. What does this remind you of? It's exponential. Compounded interest grows exponentially. So earlier I told you simple interest has linear growth. Well, compounded interest has exponential growth. You can add that in your notes back when we wrote the formula down. We've got some exponential growth for compounded interest. So it's kind of interesting because the simple interest formula makes a lot of sense and it's easy to use, but most of our interest that we actually get, like in real world situations, is usually compounded. And we're going to practice this more in class, but I just kind of want to wrap up the video by putting a little note here that simple interest is linear, compounded interest is exponential, and that's the big difference between them. All right, guys, thanks for watching all this. I hope you understood, and if you're having any calculator problems, let me know in class and I'll definitely help you out.